Last day we went to straight lines and circles. We have all these equations here for a straight line. We know the general form for a circle, standard form and the general form for a circle. We looked at finding the equation of a tangent. I showed you how to get the equation of a circle using 3 points only. I showed you both methods, right? And then I showed you the parametric equation of a circle. All right? So every time you see those parametrics, what you have is a circle. All right, so next, we want to talk about ellipse. As I told you before, a circle has two main properties. It has a center, and all the points on the circumference is equidistant from that center. Ellipse, on the other hand, it has a center, but the circumference is not equidistant around it. All right? In the ellipse, there's a major axis and a minor axis. So head up ellipse, and let's take a look at how to work with the equation of the ellipse. All right, so watch here. If we have an ellipse, right, and the ellipse has a center 0, 0. Here is its center, right? It has a major and a minor axis. So what you will recognize is that from the center, one of the distances is longer. So from the center on the x-axis to either side is longer than the center to the y-axis on either side. So this axis here, we call it the major axis. And this axis here, we call it the minor axis. Right? And in order now to get the major and minor, we need two values. We need A and we need B. So what you will see later on, underneath there, you shall see the general form here of an ellipse. X squared over A squared, Y squared and B squared is equal to 1. So an ellipse looks like this if the center is 0, 0. All right? So this here is your general form. If the center is not 0, 0, I'll show you what to do, right? Draw this, please. Right, remember, this is how it will look if the major axis is the x and the minor is the y, and if the center is 0, 0. Right, let's try a quick example. Suppose I gave you something like this. You'd recognize that, well, of course, you don't always get 2 squared, you might get 4, right? But if you look here, you'd recognize that A is 2 and Y is 1, right? So how are you going to sketch that? Go to your axis, right? You're sketching 2 here because if you look at it, the center is 0, 0. So you're sketching 2 on this side, 2 on this side, 1 on this side, 1 on this side, and then connect it up. That is your ellipse. But the equation must be in this form. Sketch it quick. Now that we have an idea of how to sketch the ellipse, let's introduce the foci. Right? Let's introduce the point of focus now. If we go back to the first one, right? There are 2 special points called the foci. C minus C, right? And those 2 special points, right? They are the same distance from the center. They are also on the major axis. And watch this here. If I were to draw a line from here to here and call that D1, and draw a line from here to here and call that D2, the sum of those values is a constant, right? So let me show you what I'm talking about. If I pick a next point here and I find the distance here, D3, and I find the distance here, D4, if you were to add up D1 and D2 and add up D3 and D4, it'll be constant. That's one of the special properties of the ellipse, right? The sum of the distances from the foci is always constant. All right? So those 2 lines in green plus the 2 lines in yellow will always be constant. Right? How do we find C now? C is the square root of a squared minus b squared if a is more than b. And C is the square root of b squared minus a squared if b is more than a. So whenever you do an ellipse, you have to show them the foci. Okay? What is the foci? The foci is a special point along the major axis where the sum of the distances from any point, constant. If I were to go much further away, like all the way down here, and I add up this and I add up that, that'll be the same distance. That'll be the same as D3 and D4. Okay? So you see our circle is always equidistant from the center. The sum of the distances from the foci is always constant. Let's go back to the next one. All right, so we need to find C. C is the square root of a squared minus b squared. That's the square root of what? 3, right? Here will be root 3, here will be minus root 3. Right? So your diagram must show the foci. Is this an ellipse? 9x squared plus 4y squared is 36. Is that ellipse? What to do? Divide everything by 36. Because the right-hand side must equal to what, Adrian? To 1, right? So you'll get x squared over 4 is equal to y squared over 9 is equal to 1. Or x squared on 2 squared plus y squared on 3 squared is 1. Okay? Sketch that fast. Right, so you have C as the square root of 3 squared minus 2 squared. So that's the square root of how much? 9 minus 4, root 5. So the major axis is the y-axis. The minor is the x. Right, mine's not perfect, but root 5, negative root 5. Right. What would happen if the center is not 0, 0? When the center is not 0, 0, the equation looks something like this. It looks something like that. There's a value here and here now. H and K will be the center. So it looks something like this. Okay? So you'll recognize that if the center is P and Q, it will look like this. Right? And then the foci will change slightly. The foci will be P plus or minus C by Q and P plus or minus Q by C. Okay, so make a note of that, please. All right, so let's take a look at this one here. Right, we'll do this one together. X minus 2 all squared on 2 squared. Y minus 5 squared on 4 squared is 1. First thing you have to make sure the right-hand side is 1. Right, so we're good to go. What is the center here, Shivish? Positive 2 and 5. And the major axis is what? X or Y? Y. So therefore, from that, we know what the center is. We know what A and B is, and we know that B is more than 0. So the center is what? 2, 5, right? So 2, 5 is around here. Right. How are we going to get all the other points around it? Real simple, right? The x-axis, A gives us an idea of how far from the center, right, on the horizontal part will be. So here, this is telling us that we're going 2 to the right and 2 to the left. So if here is 2, we're going about here, so that's about 4. That'll be 4, 5. And then we're going 2 to the left. So that'll be 0, 5. Right? I'm just trying to get it to line up. We're on 5, right? The vertical radius is like 4. So if the vertical radius is 4, here's what it's saying. It's saying that from here to here have to be 4. And from here to here have to be 4. So 5 plus 4 is 9. So that point there is 2, 9. And this point here is 2, 1. Now you have the endpoints, and you connect it up like this. Right, so I wanted to consider, you see like A is like the horizontal radius. B is like the vertical radius. All right, this B value tells us that you're moving 4 away on the vertical side up from the center. So you're going up 4, down 4, right? And last thing, we have to show the foci. All right, so you use a little formula I give you and you draw the foci. Right, so it looks like this. The ellipse has the endpoints, the ellipse has the center and the foci. The major axis is the y-axis. So the foci, I'll write in black. The foci is here and here, right? So the foci is h by 5. Sorry, let me take off h. It's 2 by 5 plus c. C was root 12. And here, 2 by 5 minus root 12. It will boil down to kind of just going back here and remembering this, right? Sketch out fast. Right, so that's what, root what, 25 minus 16, that's 9. So C is 3, nice. All right, so your center is minus 2, 3, right? Right, the major axis is the x or the y? The major is the x, right? So you're adding 5 to the right. 1, 2, 3, 4, 5. So I got 3, 3. And then I go in the next way and I got what? 3 minus 7. Yeah, minus 7, 3. Right, and then you go up what, 4? You go up 4. So right now we are 3, so it's going up to 7. So that's minus 2, 7. What's the value under here, Shivish? So the value is minus 2, minus 1. And then you connect it up. And then we need to put in the foci. Where will the foci be, on the x, on the horizontal, or the vertical? On the horizontal. So it will be at what? So it will be right here, 3 away here, and 3 away here. So it will be minus 5, 3, and 1, 3. All right, I want to give you one more form, right? Sometimes it don't look this nice. We had to get it in this form. This form easy for us to read it off, but sometimes it looks like this. Sometimes it's 8x squared plus 18y squared minus 96x plus 144y plus 288 equal to 0. What does that look like? It might look like a circle, but here's what, this value here and this value here is not the same. If they were the same, then it's a circle, right? Because you could divide everything by 8 or 18 or whatever. So what we need to do now is to put this in a form that's easy for us to read it off. Okay, what you just do? You just bring the x's together. 8x squared minus 96x, 18y squared plus 144y, and let's move across that 288. All right? And here we're going to do. See this here? We're going to complete this square for each one. Just in case you all forgot, h is equal to b on 2a, and k is equal to c minus ah squared. All right? So we're going to complete the square. Right, so I'll factor out 8 here. I'll get x squared minus 12. And here I'll factor out the 18. And I will get y squared let's find h and thing one time. Right, so it's minus b on 2a. Right, so that'll be minus 12 on 2 by a. A is 1. all squared, plus k. K is c, but remember c is 0, right? So it's 0 minus a. A was 1. What is 18 into 144? It's 6. It's 8. Okay, thanks. Sorry. All right. So I just complete the square inside here. So that'll be 8 by, open brackets, x minus 6 squared plus minus 36. And then I'm going to multiply everything by 8. 8 by x minus 6 squared minus 8 by 36. All right, next part, plus 18, open brackets, y plus h is b on 2a. So it's b on 2 by 1 all squared plus, again, c is 0. 0 minus a is 1. 8 on 2 is 4. 4 squared. Close brackets. So that's plus 18 by y plus 4 all squared plus minus 16. And that's it there. You end up with plus 18 by y plus 4 squared minus 18 by 16 is equal to minus 288. Right, so you end up with 8 minus 6 squared plus 18 by y plus 4 squared is equal to minus 288 plus, I'm bringing out all numbers on the left side. So after you complete the square, bring all the x's, bring all the x and y on that side and bring all the numbers on the next side. All right, so the last part, write it on top. You'll get 8 by x minus 6 squared plus 18 by y plus 4 squared. When you work out the right-hand side, you're supposed to get 288, I think. Yeah, 288, nice. And now it might look a little better because if you divide everything by 288, what's 8 into 288? 36. Oh, so we end up with x minus 6 squared over 36. 18 into 288 is 16, right? And you'll get y plus 4 squared, and here's 1. Right? So 10 years after, we end up with this. It never came before, but I'm just telling you how to handle it. Right? All I want you to remember is this. If you see something like this in an exam, complete the square here, complete the square here, and then you'll get in a form like this. Right? And then you should be able to make the right-hand side 1. So the parametric form of an ellipse is this. Copy it down. What's the difference between the parametric form of a circle and an ellipse? All right, let me put it right next to each other here. Right, the values here is the same. Right, the coefficient of cos and sine is the same because it has a radius. But here is different. So that's how you know an ellipse and a circle. But suppose you don't remember it. Right? What you do again to find the equation? Right, well, you make cos the subject and sine the subject and good. Nice. Find the Cartesian of that. We'll sketch it, let's work it out. Right, so cosine theta is equal to x minus 4 and 2, and sine theta is y minus 3 and 4. Right, when you square it, you'll get something looking like this, and you get an equation like this. And that's it. You write down the center and write down the foci. Okay, so your center for 3, you find C, and you tell them what the foci is, right? Don't leave out the foci, please. When you're defining an ellipse, you must have the center and the foci. The foci kind of acts as a radius. Right? The reason the plus and minus there is you're doing it twice, right? 4 by 3 plus root 12, 4 by 3 minus root 12. All right? So far, we did the circle and we did the ellipse. The last thing we have to do is the parabola. Look how the parabola looking there. The parabola looking a little confusing, but really and truly, you all did these already. All recognize this? And that's a max and a min, right? Those are parabolas. These are also parabolas. But in here, y was equal to x squared here, y squared is equal to x. So those are the general parabolas that we need to know. In order for you to draw a parabola, here's what you need. You need a foci again, and you need something called directrix. So on this, all we have to do is this. Every single point on the parabola is equidistant from the foci and the directrix. So it might be one in the middle here. It might be somewhere here-ish. The distance from here to here, right, has to be the same all the time. It has to be equidistant from those two things all the time. If you were to plot it out, you will get something like this. Right, not perfectly to scale, but it will look something like this. And that shape is your parabola. Every single point on the parabola is the same distance from the focus and the directrix. Okay, so we have to learn the parabola. We have to be able to, especially these here, identify when a is more than 0, a is less than 0. And then learn the parametric. So the parametric for the parabola is this and this. All we have to do is make t the subject and plug it in the next one. And you'll get the equation. Okay? So you have to learn all the parametric forms, right?